Go find a penny, or a quarter, or even just a set of house keys. Hold them in your palm for about 10 seconds. Squeeze them tight until your hand gets a little warm. Now, put the metal down and smell your fingers. You know that sharp, tangy, unmistakable scent? We have called it the smell of metal our entire lives. But here is the thing that is about to break your brain. Metal has no smell. Not even a little bit. If you took a block of pure copper or a bar of iron and put it in a vacuum-sealed, sterilized glass box, you could sniff it for 100 years and you would smell absolutely nothing. What you are smelling right now on your hand is not the coin. It is actually a chemical reaction involving your own body. You are quite literally smelling the scent of your own skin breaking down. Think about the last time you spent an hour at the gym gripping a pull-up bar, or the way your hands smelled after riding a bicycle with metal handlebars. That heavy, industrial aroma feels like it is coming from the object, right? We even use it as a descriptor. We say things like, "This water tastes metallic," or "That room smells like old pipes." But chemically speaking, metals like iron, copper, and zinc do not have a vapor pressure. That is a fancy way of saying they do not evaporate into the air at room temperature. And if molecules do not evaporate and float into your nose, your olfactory receptors have nothing to detect. So if the metal's not moving, why is your nose screaming metal? To solve this, we have to look at what happened the second your skin touched that coin. Your skin is covered in oils, specifically something called lipid peroxides. You also have sweat, which is a mix of water, salts, and acids. The moment those skin oils hit the surface of the metal, a tiny invisible chemical explosion happens. The metal acts as a catalyst. It takes the electrons from your skin oils and shatters them into tiny volatile molecules. One specific molecule is the main culprit. Scientists call it 1-octene-3-1. It is a mouthful, I know, but it is the secret ingredient that creates that signature coin smell. And here's the kicker. Humans are insanely good at smelling this specific molecule. We can detect it even if there are only a few parts per trillion in the air. We are practically bloodhounds for the smell of our own skin reacting to iron. But why does this feel so familiar? There is another place you have smelled this exact scent, and it is a lot more macabre. Think about the smell of a fresh nosebleed or a cut on your finger. Blood has that exact same metallic tang. For decades, people thought blood smelled like metal because blood contains iron. It makes sense, right? Hemoglobin is packed with iron to carry oxygen. But remember our rule. Iron has no smell. So why does blood smell like a jar of pennies? It is because the iron in your blood is doing the exact same thing to your skin oils from the inside out. When blood is exposed to air and touches your skin, the iron atoms trigger that same chemical breakdown. You are not smelling the iron in the blood. You are smelling the blood turning your skin into that 1-octene-3-1 molecule. We are essentially walking, talking chemistry sets, and the smell we associate with the Bronze Age is actually just the smell of us. This is where it gets a little weird. If you want to prove this to yourself, you can try a little experiment at home. Take a coin and wash it thoroughly with soap and water. Then put on a pair of latex or nitrile gloves and smell the coin through the glove. Nothing. Now, drop that coin into a glass of distilled water. Still nothing. But the second you touch that coin with your bare, sweaty palm, the reaction starts. It takes less than 1 second for those molecules to form. It is one of the fastest chemical reactions your body performs on a daily basis. Now, you might be wondering, why would humans evolve to be so sensitive to a smell that technically does not exist in nature? I mean, iron bars and copper coins are relatively new in terms of human history. Our ancestors were not exactly carrying around spare change in the Serengeti, but they were hunters, and they were prey. Many evolutionary biologists believe our noses are tuned to this metallic smell because it is the smell of blood. Being able to track a wounded animal or detect if a predator is nearby and bleeding was a massive survival advantage. We did not learn to smell metal. We learned to smell the chemical byproduct of blood touching skin. And then we just happened to start making tools out of materials that trigger that same reaction. When you hold your car keys, you are accidentally triggering a prehistoric hunting instinct. This also explains why some people seem to smell more metallic than others. Have you ever noticed that after a long day, some people have a very strong scent on their skin, even if they have not been touching coins? This comes down to your individual skin chemistry.
The amount of oil your body produces, the pH balance of your sweat, and even what you ate for dinner can change how rapidly your skin reacts with metal surfaces. If you have a high level of skin acidity, you are basically a super catalyst. You could touch a stainless steel fridge and leave a scent trail that a tracking dog could follow. Speaking of stainless steel, have you ever wondered why it is called stainless? Or why it does not seem to smell as much as a copper penny? Stainless steel is treated with chromium. This creates a microscopic, transparent layer of chromium oxide on the surface. This layer is like a shield. It prevents the iron atoms from ever coming into contact with your skin oils. No contact means no reaction. No reaction means no smell. This is why high-end kitchen appliances do not make your kitchen smell like a workshop. But if you scratch that protective layer or use a cheap alloy, the iron is exposed, and the funky skin-smelling party starts all over again. Let us look at the flip side. If the smell of metal is actually the smell of us, what about the taste? We have all done it. As a kid, you probably put a penny in your mouth, which, looking back, was a terrible idea for a lot of reasons. But you remember that taste. It is bitter, sharp, and electric. That is not just your nose playing tricks on you. When metal touches your tongue, the same reaction happens with your saliva. But there is an added layer. Because metals are conductive, they can actually create a tiny, tiny electrical current in your mouth. You are literally tasting a microscopic battery. This is why people with metal fillings sometimes complain about a metallic taste if they bite down on a piece of aluminum foil. It's called galvanic shock. 2 different metals plus salty saliva equals a literal electric zap to your nerves. So the next time you are at a checkout counter and the cashier hands you a pile of warm change, take a second to really think about what is happening. You are not just holding currency. You are holding a catalyst that is currently harvesting electrons from your body to create a scent that has helped keep your ancestors alive for millions of years. It is a deep biological connection between the inorganic world of minerals and the organic world of your body. It also changes the way we think about history. Think of the knights in the Middle Ages. We imagine they smelled like cold steel and oil. In reality, they probably smelled like a giant walking pile of 1-octane-3-1. They smelled like a massive amplified version of that penny in your pocket because their sweat was reacting with every square inch of that suit of armor. The smell of the battlefield was not just smoke and dirt. It was the smell of thousands of men's skin oils being vaporized by their own equipment. Does this make you feel a little bit like a superhero? Or maybe a little bit gross? It is a bit of both. We like to think of our bodies as being contained within our skin, but we are constantly reacting with the world around us. We are changing the chemistry of the objects we touch before we even realize we have touched them. You are a walking laboratory, and your sense of smell is the lead scientist. Before we wrap this up, I want to give you one more fun fact to keep in your back pocket. This metallic reaction is so consistent that it is actually used in forensic science. Investigators can sometimes detect if a person was holding a specific type of weapon or tool based on the chemical residue left on their palms, even if they washed their hands. The reaction goes deep into the pores of your skin. It's like a temporary chemical tattoo. It's amazing how a simple, everyday question like why do coins smell can lead us down a rabbit hole of evolutionary biology, chemistry, and human history. It reminds us that the world is rarely what it seems. We think we are smelling the world, but often we are just smelling ourselves interacting with it. The next time someone says they love the smell of a new car or the scent of an old toolbox, you can be that person who leans in and says, actually, you were just smelling your own oils decomposing. You might not get invited back to the party, but at least you will be the smartest person there. I want to know if you have ever noticed the scent in a weird place. Aside from coins and keys, what is the strangest object that has ever left that metallic smell on your hands? Was it a piece of playground equipment, a specific piece of jewelry, or maybe something in your kitchen? Let me know in the comments because I read every single one of them. If you found this deep dive into the hidden chemistry of your daily life fascinating, make sure to hit that like button. It really helps the channel out. Share this video with that one friend who is always fidgeting with their keys. And don't forget to subscribe and turn on notifications so you never miss another mystery solved.
Thanks for watching, and I will see you in the next one.